Hey everyone, in this session, let's understand extreme gradient boosting or XGBoost algorithm. XGBoost is a very popular and powerful machine learning algorithm belongs to gradient boost. If you are not aware about gradient boosting, I have a dedicated video for it in the same playlist. You can watch it before watching XGBoost because XGBoost belongs to the gradient boost algorithm family. It works on boosting technique of ensemble learning. Again, if you are not aware about ensemble learning, I have a video of ensemble methods what you can watch for details. In boosting technique of ensemble learning, we use a sequence of weak learners in order to create a strong learner. That is how boosting works in ensemble learning method. In our previous session, we have discussed about gradient boost. In this session, we will understand the advanced version of gradient boost, which is nothing but extreme gradient boost. In this session, we will understand the theory of XGBoost. We will see how can we implement it in our Python code. We will write some code in Jupyter notebook to solve some classification problem with the help of XGBoost. And finally, we will see how XGBoost works internally. Hope this session will be helpful for you to understand XGBoost end to end. Let's understand why XGBoost is very popular in machine learning community. It has a number of advantages. XGBoost known for its speed and performance. It supports both parallel and distributed computing. Hence, we can use XGBoost the places where you need performance. It has auto regularization to prevent overfitting problem. XGBoost provides a mechanism to calculate the feature importances. Apart from these advantages, we have a very wide community support for XGBoost. We will get a dedicated user guide for XGBoost and a huge community help as and when you need for implementing XGBoost for your problem statement. Let's also understand the disadvantages of XGBoost so that we can identify where should we use XGBoost and where we should not. XGBoost consumes a significant amount of memory. Hence, whenever you are implementing XGBoost, you have to keep it in your mind that it might need significant amount of memory if your data set is large. It is also sensitive for noisy data. Whenever we will be using XGBoost, we have to take special care on the pre-processing and cleaning of the data before feeding it into the model. With this, we have realized why XGBoost is a very popular machine learning algorithm and what are the things we have to keep in our mind before choosing XGBoost as our machine learning model. Let's understand how can we implement XGBoost in a Python code. In order to implement XGBoost, we have to install XGBoost library first. Remember, XGBoost does not come as a part of scikit-learn library. Hence, we have to install XGBoost separately in our machine. We know how to install any Python library in our machine. We have to use pip install for the same. Once we have XGBoost library in our machine, we can easily import it for our usage. We will write import XGBoost as XGB, which is the alias name of XGBoost, what we have provided for our ease while writing the code. To create a model, we can use the constructor called which is XGB classifier. Once we have the model, we can train it with fit method. Fit method takes the training data as its input and train the classifier. Remember, XGBoost has both classifier as well as regressor. In our example, we will be solving a classification problem. Hence, we are creating a classifier. Hence, we are creating XGBoost classifier model. We can apply score method on top of a well-trained XGBoost classifier model to understand the accuracy of the model. While using score, we have to pass the test dataset as input. Apart from classification, we can also use a well-trained XGB classifier to identify or evaluate the feature importances. Using feature underscore importances underscore attribute, we can identify the most important features from our dataset for a particular problem statement. Let's jump to Jupyter Notebook. We will practically implement all these in order to solve a classification problem. We are in our Jupyter Notebook. Let's first install XGBoost in our system. We will be running pip install XGBoost. In my computer, I have already installed XGBoost. Hence, if I run this, it will tell requirement already satisfied. But in your computer, if XGBoost is not been installed so far, pip install will help you to install XGBoost in your system. You should have internet connection to run pip install XGBoost. Once we have XGBoost library installed, we can import the same. We can import XGBoost in our notebook. We are importing pandas to perform some data preparation step. Importing XGBoost because we will be using XGBoost classifier model to solve a classification problem. We are using train test split method from sklearn.model selection because we will split the entire data set into training data and test data. In this particular session, as an example, we will be predicting the iris flower species. It will be a classification problem. Hence, we are loading iris data from sklearn.dataset. I am also importing matplotlib in order to perform some data visualization. If you are not aware about pandas or matplotlib, I have separate playlists for them. I'll be adding those links in the description section. Let's now concentrate on the data preparation part. We are loading iris data and getting a number of directories for that dataset, where data will have the independent columns. Feature names are nothing but the names of independent columns. Target will have the dependent column. Target names will have the different classes of iris flower species. Let's first understand how we are creating feature data frame out of this iris data. We have 4 different independent variables: sepal length, sepal width, petal length and petal width, which are nothing but the properties of the iris flower. We are also creating the target data frame, which will have the species. Our target is to predict a particular species of iris flower based on specific sepal length, sepal width, petal width values. We have 3 different species of iris flower: setosa, versicolor, virginica. Here 0 means setosa, 1 means versicolor, 2 means virginica. So based on the independent variable values, we will be classifying the iris flower one among these 3 different classes. It could be either setosa or versicolor or virginica. Hope you have realized the problem statement now. With the help of train test split method, we will be splitting the entire dataset into training data and test data. Here we are keeping 20% of the data for our test. Remaining 80% of the data will be used to train the model. With this, our data preparation step has been completed. Let's now understand how can we create the XGBoost model which will solve our classification problem. We are creating the classifier with the help of the constructor called XGB classifier. As we have discussed it during our theory session, that XGBoost has both classifier and regressor. In our specific problem, as we are solving a classification problem, we are creating XGB classifier. However, in your case, if you want to solve a regression problem, you have to create XGB regressor model. In our commented line, as you can see, apart from default hyperparameter values, we can also specify a specific hyperparameter values while creating the classifier. If you do not pass anything, all these values will be set to the default values. However, in order to enhance the accuracy of the model, you can always play with these hyperparameters, also known as hyperparameter tuning, which is a very essential step for any data scientist or a machine learning engineer. Let's create the model. Once we have the model, we can always train the model with the help of training data. Let's see the score for our trained model. As you can see here, the score of the trained model is 1. That means 100% of the time our model will predict the species of iris flower accurately. As we have less data set and we have a very high performance model called XGBoost without performing any hyperparameter tuning, see how accurate model we have created to solve this classification problem. That is the beauty of XGBoost model. That is why XGBoost model is a very popular model across the community. Apart from that, with the help of trained XGBoost model, we can identify the feature importances. If you have a number of features in your dataset, you can always identify the most important features among all the features available in your dataset. For that, you have to use feature underscore importances attribute. With the help of matplotlib, let me plot the feature importances in a horizontal bar graph. You can easily understand that among 4 different features what we have for this particular problem, the most important feature is petal length. Second most is petal width, and then sepal width and sepal length respectively. With the help of feature importances, you can understand the dataset well and easily drop the features which are of no use. In other words, which are not contributing during prediction. So far, we have realized what are the advantages and disadvantages of XGBoost model and how we can implement XGBoost model to solve a classification problem. In our next slide, we will be discussing on the mathematics behind XGBoost model or how XGBoost works internally. XGBoost starts with a very base model. The initial model will predict the mean value of your target column. In our case, if we assume the target column of a binary classification problem is either 0 or 1, then initial prediction will be 0.5 in our case. We will assign the initial prediction for all the samples in our entire dataset. Then we will identify the errors we have made with this initial model, also known as pseudo-residual value. Pseudo-residual can be calculated easily by subtracting predicted value from the actual value. Once we have the pseudo-residuals for all our samples, we will try to create our next model. Remember, as it is a boosting technique, we will be creating a number of weak models in order to create a strong model. We will be building a decision tree to predict the pseudo-residuals value what we have calculated in step number 2. So our decision model will not predict the target column for our classification problem. Rather, it will predict the pseudo-residual values. In order to choose the important features, we calculate similarity score for each node of our decision tree. Similarity score can be calculated with this mathematical equation, which is nothing but summation of residual square by summation of probability into 1 minus probability plus lambda, where lambda is the regularization value. This equation is valid for classification problem. If we have a decision tree something like this, we calculate the similarity score for this, and then based on some branching technique, we create the child nodes here. We also create the similarity score for each node and calculate something called gain. We can easily calculate gain with this equation. Similarity score of left node plus similarity score of right node minus similarity score of root node. We evaluate gain in order to prune the tree. Tree pruning will reduce the overfitting problem. We use some value called gamma, which is nothing but the minimum acceptable node gain. If the gain value is more than gamma value, then we will keep the node. If the gain value is less than gamma value, we will drop the node. We will not be splitting the node. In that way, we are limiting the size of the decision tree, and in turn we are reducing the overfitting problem. Now it's time to calculate the output with the help of the equation, which is nothing but summation of residuals by summation of previous probability into 1 minus previous probability plus lambda. Again, lambda is nothing but the regularization value. Using lambda, we are also reducing the overfitting problem of the model. Once we calculate output of a weak model, we evaluate the new prediction probabilities, what we predicted initially in the step 1. Now we will be refining it further. That can be easily calculated using this mathematical equation. Previous log odds plus eta into output of tree 1. Tree 1 is nothing but the output of an weak model plus eta into output of weak model 2 and so on. Remember, here eta is nothing but the learning rate. Using eta, we are regulating the influence of the weak models in our final prediction. We will repeat all these 6 steps until our required number of trees are built, because we can pass some hyperparameter called n estimator, where we can limit the number of weak models we want in our XGBoost model, or residuals are very small. In other words, the errors are very small, what we are calculating in step 2. If we meet either of these two cases, we will stop repeating these 6 different steps. Hope now you have realized how XGBoost classifier is working internally and what are the mathematical equations you have to understand in order to understand the steps performed by a XGBoost classifier. Let's summarize the session. In this session, we have discussed about extreme gradient boosting or XGBoost algorithm. XGBoost is a machine learning algorithm which is very popular and powerful. It works on boosting technique of ensemble learning. That means a sequence of weak learners will be added together to create a strong learner. We know what are the advantages and why XGBoost is so popular. We also know the disadvantages of XGBoost model, so that we can take care of few points before implementing XGBoost to solve our machine learning problem. We know how to use XGBoost in our Python code, and finally we know what are the steps XGBoost model uses internally in order to solve a classification problem in machine learning domain. Hope you have enjoyed this session. Thanks a lot for watching this video.